Okay, let's look at this question here, which was taken from the year 2024 paper 1 question 10. So using the substitution, we're asked to simplify it to this guy. Oh, shouldn't be an issue. Yeah, okay, great. So we're gonna just show it. So u is equals to 4x plus 1. Okay, that's it. Then this basically we want to change all these, right? In terms of fx, we want to change to a function of gu. Then same with this one, we need to change to du. So differentiate with respect to x first. So basically du dx, okay, this is our rule, plus 1 half. So this is half 4x plus 1 minus half under 4. Okay, so this case here, what we'll get is actually du dx equals to 2 square root 4x plus 1. Okay, then we will get du, basically this guy, this is du equals to 2. We want du or dx, but we need dx, right? So dx, maybe I just multiply the other side, 4x plus 1, du equals to 2 dx. Then we're going to write dx is equals to 4x plus 1 over 2. Okay, so this guy here, we get dx is this guy. Now, if your school teacher don't allow, just erase it for this step here. But like I said, it's found in all calculus textbook, university textbook, right? This way to write it. So I often say that it really doesn't matter. I think this is easier. So you make dx. I know some school teachers do not allow this, but you just go and check Oxford, Cambridge University textbook. Even my prof at uni writes this way. Okay, so it doesn't make sense. If not, just erase. So anyway, this guy, we can just rewrite them. Our goal here is to change everything. So this guy is our u. This guy our u, right? Just change the u here. Then after which we need to find what is this x minus 2 here. This x minus 2 for the denominator. Not sure what it is, but we could make u the subject. So this case, if I were to rewrite this guy, okay, this guy will be u squared equals to 4x plus 1. So we get x is equals to u squared minus 1 over 4. Okay, so I'm gonna just rewrite this. Why? This one will be our u, because that's our u. Then the denominator x is equals to u squared minus 1 over 4 minus 2. Right? Dx will be square root 4x plus 1 over 2 du. Now remember, you do not want to see your x, bro. Just like in real life, bro. So this guy here, change this to u. Right? This is u. That just u there. So this guy will be u. Then I'm gonna get u. Okay, this similar. I'm gonna multiply by 4 here. Multiply by 4 here. Okay. So that'll be 4u. Then it'll be u squared minus 1 minus 8. Okay, multiply by 4. So then this would be my u. U over 2 du. Okay. So just simplify them. This is 2, 1, 2. Let's write it down. This will be u squared over u squared minus 9 du. Is that what they asked us to show? Oh, there's a 2 there. Thankful for showing question. So that's it. Okay. So shown. Great. So let's look at part 2, part B. Let's look at part B. The region R lies in the first quadrant and is bounded by this guy, the line x equals to 6, this guy and this guy. Can I just draw it out first? Obviously, bring out a GC, plot in the graph and hope for the best. Okay. So the other thing is, understand there's a VA, the vertical asymptote. Okay, the vertical asymptote here is x minus 2 equals 0. So it's x equals 2. So I'm going to plot this in the GC here. This is parametric mode, change the function. There you go. Then put this out in, then you just zoom, you get this guy, right? So just draw it out. So 3, 0. But I'm not sure if 0 is negative half here. So we're going to plot this out. So you just make sure that you can just zoom box to, don't underutilize your white space, right? So just key in GC. I'm just going to zoom to this area here and just try and sketch this guy out. There's horizontal asymptote. It appears to be y equals to 0. We can assess that later. We'll look at that. Okay. So this guy, as x goes, oh, interesting. Here you see, it goes to a value. Okay, we can just trace and put a super huge value. I'm not sure you can put 100 in. It is invalid. Okay, so we go. Then I'm going to trace. Okay, actually we could assess and see what is the horizontal asymptote. It may not be so straightforward. Okay, so I think that because the degree on top is smaller than the as in the it's a root, right? The degree is smaller. So basically, when x goes to infinity, y will the top will be much smaller than the denominator. So y is goes to 0. Okay, so y goes 0 is actually a horizontal asymptote. That's how you assess. Then you just plot the graph. So you should have a vertical asymptote. Okay, so when x equals to 0, we already assessed that. So let me just send as trace 0. You will get 0 and negative half. Right? So this is the graph here. Like that. Is it? Like that. Okay. There's 0, common negative half. After which this guy is like that. Okay. This is the what do you call it? The horizontal asymptote here. Y equals to 0. Okay. So they asked us to sketch a graph just now. What was it? I mean the region R. Let's look clearly the region R. So we have 12. X equals to 6. So x equals to 6 will roughly, okay, very far away. Maybe we just don't have to draw the scale. Maybe I take my word back. We just draw. So 6 is roughly here. This is x equals to 6. Then we have got x equals to 12, which is half of it. So this is 2, 4, 6 roughly here. Because I think in the GC, if I put 6, trace 6, we roughly here. Then, yeah, x equals to, x equals to 12. So obviously the GC, I'm going to adjust my window setting. So -1, I'll put this as 15. Graph it. Then I'm just going to put trace 12. Trace 12 will be 7 out of 10. The reason why I need to put that is because I look at this y, this is half. Okay, 7 out of 10 is obviously more than half, is 0.7. So I'm going to draw it out. Half will be roughly here. Okay, below the y value. Okay, so this is it. Then we need to shade the region R. Shade it. Okay, so the region R will be here. I'm going to shade it here. This is region R. Be bounded by the curve. So on, this is R. Okay, then after which what we need to show is find the exact area R giving our answer in A plus B, which means we need to use this guy. Okay, this guy there. So we take area under the graph. Okay, minus off the small rectangle below. The small rectangle below is important. This rectangle here. Okay, so you can use y1 minus y. Okay, basically if this is y1, subscript this. So I always tell students that if whenever you have more than one curve, you just subscript it. This is y2. Then what we need to do is just take top minus bottom. Okay, so the y2 is half. There you go. This is what I do. So I think the first one is not an issue. The first one we already found the what do you call it? The on the first part, the integration by substitution, because they want the exact. So this case now just be mindful. I think the problem is always students forget to change the boundary. Okay, the boundary is important. This 2u square, oh, there you go. Is exactly the same, right? So you need to change the u. U is square root 4x plus 1. So when x is 12, u is 7. So when x is 6, u is 5. Okay, so there you go. So if I were to change this, this will be 5 to 7. 2u square, or u square minus 9du. Okay, for the other one will be just a normal integration, half x here. Then we just put 6 to 12. Okay, that's it. For this guy, do a long division. Okay, because it's an improper fraction, just do a long division. There you go. Here, you put 2u square minus 18. This will be 18 here. From here, I'm gonna get 5 to 7, 2 plus 18 over u square minus 3 square du. So this guy I'm gonna just use MF27. So that's it. So this guy here I'm gonna use half 12 minus 6. So not an issue here. Just 6, so it's 3. This will be 2x plus 18. So this is the MF27 that we get. The 18, let's just bring it up lah. Okay, so then just substitute it in, find the value there. 75 minus 3. There you go. Then we just manipulate. There you go. Then what we get is 1 plus 3 ln 8 over pi. That's that. The next part is we were told to find the volume of r rotated 2 pi about the x-axis. So it is just around this, right? So not an issue. Just take the top curve minus the bottom curve, right? So that's it. It's a 3 marks, and you don't need to integrate it because they never ask for exact. So just key in GC, that's all. So this is what you do. You just take the what you want is something like that. Basically, this is the required volume. You need to take the entire thing. You remember when you take the volume, you cannot control where it projects. You project the curve down the x-axis, and it will take the entire thing, right, including the cylinder below here. Then you need to be empty shell here, so that's why you minus off the cylinder over here. Okay, so it looks something like that. This is how it looks like. So that's the idea there. What we need to do is just take y1 square, so the required volume, just take y1 square minus y2 square dx. Rotate about the x-axis is dx, so pi 6 12, then you just square the entire. Just key in calculator. Okay, just key in calculator. Key in calculator to get the answer. So this don't integrate. I think a lot of times you're gonna waste time if they never ask for exact number. 9 function integral, then you just take from 6 to 12, then you just key in. Okay, so this guy will be 4x plus 1 top, then the bottom will be x minus 2 square. Okay, then you just put the minus 1, put that bottom, then you just square, then this will multiply by pi. Making calculator will be negative 3. How come it's supposed to be squared? Squared. Sorry, I wrongly. This guy is y2 is half. And y2 is half. Yeah, how is this half? This is half. There you go. Okay, so this will be our wrong 0.5 square. Enter, that will be your answer. Okay, the question wants 2 dp 4 dp 2 dp, so 2 dp would be 11.04 cubic units. Okay, that's how I do this question here.